the entire universe will be aware of this one explosion.
It's a star also that is on the verge of death.
Far away in the constellation of Orion, a red supergiant star named Betelgeuse shines bright, but not for much longer. This colossal star, over 700 times larger than our Sun, is on the brink of something truly spectacular, a supernova explosion. Betelgeuse is one of the largest and most famous stars in our galaxy, but its future is uncertain and potentially catastrophic. For years, astronomers have been captivated by this star's strange behavior, its rapid dimming and brightening, dust ejections, and evidence that it could explode at any moment. Could we be witnessing the final days of Betelgeuse? How would its supernova impact our planet, our galaxy, and the universe? Join us on Mystery Beyond Reason as we journey through the science, theories, and mysteries surrounding one of the cosmos's most fascinating stars. We'll unravel the secrets of Betelgeuse's life cycle, the nature of supernovae, and what we can learn from this giant's impending death. In 2019, astronomers noticed something unusual. Betelgeuse's brightness dropped by nearly 25%, and the world was buzzing with excitement. Many thought this was it, that Betelgeuse was finally about to explode into a spectacular supernova. But Betelgeuse isn't going supernova just yet. NASA and the European Southern Observatory closely monitored the star and discovered that the dimming was likely due to dust ejected from Betelgeuse's surface, not an immediate prelude to an explosion. Betelgeuse, while nearing the end of its life, still has some time left, possibly 100,000 years before it reaches the supernova stage. Currently, the star is in the late stage of core carbon burning, which is one of the final stages in the life of a star before it collapses. But what exactly does this mean? How does a star like Betelgeuse prepare for such a cataclysmic end? To understand Betelgeuse's potential explosion, we first need to explore the life cycle of stars. Stars are born, live, and die in cycles that can last from millions to billions of years. But stars like Betelgeuse live fast and die young compared to smaller, stable stars like our Sun. Stars are born from vast clouds of gas and dust called nebulae. As gravity pulls this material together, it forms a protostar, eventually igniting nuclear fusion. In their main sequence phase, stars burn hydrogen into helium, which powers their brightness. This phase is stable and long-lasting for stars like our Sun, but for massive stars like Betelgeuse, this stage is much shorter. Betelgeuse, a red supergiant, is in the final stages of its life. It has moved beyond burning hydrogen and is now burning helium, carbon, and heavier elements. This burning process causes the star to expand dramatically and become unstable, setting the stage for its spectacular death. Right now, Betelgeuse is undergoing a phase of rapid change. As a red supergiant, it has already exhausted most of the hydrogen in its core. Now it's burning helium into carbon, oxygen, and other heavier elements, which is a clear sign that the star is nearing its end. As Betelgeuse burns through these heavier elements, it becomes more unstable. The core of the star contracts, while the outer layers expand and contract in a process called pulsation. This pulsation causes the star's brightness to vary over time, and that's why we've seen Betelgeuse dimming and brightening in recent years. Eventually, Betelgeuse will reach a tipping point. Once it can no longer sustain the fusion of heavier elements, the core will collapse under its own gravity, triggering a supernova explosion. But before that happens, Betelgeuse will continue to undergo violent shifts as it nears the end. So what exactly happens when a star like Betelgeuse explodes into a supernova? A supernova is one of the most violent events in the universe, a catastrophic explosion that occurs when a massive star can no longer support itself. When Betelgeuse's core runs out of fuel, it will collapse under the immense pressure of its own gravity. This collapse happens in mere seconds, causing a shockwave that blasts the outer layers of the star into space. The resulting explosion will release more energy than our Sun will emit in its entire 10 billion-year lifetime. Supernovae like this one play a critical role in the universe. The heavy elements formed in a supernova, such as iron, gold, and uranium, are scattered into space and eventually become part of new stars, planets, and even life itself. One of the most puzzling aspects of Betelgeuse's behavior has been its dramatic dimming and brightening. In late 2019 and early 2020, the star's brightness dropped so significantly that it raised alarms among astronomers. Was this the sign that Betelgeuse was about to explode? After careful study, NASA and Hubble discovered that the dimming was caused by dust ejections. Betelgeuse had expelled a huge amount of material from its outer layers, and this material formed a dust cloud that blocked part of the star's light. But this wasn't the first time Betelgeuse had dimmed. It has been undergoing these fluctuations for centuries, but never as dramatically as in recent years. Astronomers believe this may be a sign that Betelgeuse is entering its final phases, with more violent ejections to come. The next generation of space telescopes is giving us an unprecedented view of Betelgeuse. The James Webb Space Telescope, JWST, and NASA's Hubble Space Telescope are providing detailed observations of Betelgeuse's atmosphere and behavior. The JWST uses infrared technology to peer through the dust surrounding Betelgeuse, allowing scientists to see the star's surface and detect temperature changes. This data is crucial in determining how close Betelgeuse is to exploding. NASA is also using the Hubble Space Telescope to monitor the star's activity, looking for patterns in its pulsations and dust ejections. These combined observations give us the clearest picture yet of how a star dies and what we can expect when Betelgeuse finally goes supernova. In a surprising twist, a new study suggests that Betelgeuse might not be a single star after all. It could be two stars. Some scientists now believe that Betelgeuse may have a companion star orbiting it, which could explain its unpredictable brightening and dimming. This idea changes everything we thought we knew about Betelgeuse. If it does have a companion star, it could be influencing the star's behavior, including the dust ejections and brightness changes we've seen in recent years. Could this companion star be what's responsible for Betelgeuse's strange fluctuations? This theory is still being explored, but if true, it opens up a whole new realm of possibilities for how Betelgeuse's supernova might unfold. A recent theoretical study proposes an even more fascinating idea, that Betelgeuse's mysterious behavior could be caused by a sun-like companion star. This companion might be responsible for the periodic brightening and dimming we've observed. This theory suggests that the two stars are in a binary system, with the smaller star orbiting Betelgeuse and interacting with its outer layers. This interaction could be causing material from Betelgeuse to be ejected into space, leading to the dust clouds we've seen. While this theory is still being tested, it could explain why Betelgeuse behaves in such unpredictable ways. The presence of a companion star might also change how Betelgeuse will eventually go supernova. When Betelgeuse finally explodes, the effects will be felt across the galaxy. While Earth is far enough away to avoid any direct harm, the explosion will release massive amounts of radiation, including gamma rays and X-rays. This radiation will affect nearby stars and planetary systems, potentially altering their magnetic fields and atmospheres. The debris from Betelgeuse's explosion will eventually mix with the gas and dust in our galaxy, contributing to the formation of new stars and planets. Betelgeuse isn't the only star nearing the end of its life. There are other red supergiants and hypergiants in our galaxy that could explode in similar fashion. One such star is Antares, located in the constellation Scorpius. Like Betelgeuse, Antares is nearing the final stage of its life. Astronomers are closely monitoring these stars, using the lessons learned from Betelgeuse to predict when and how they will explode.
Betelgeuse or Betelgeuse, it's a red giant star. If you put it where the sun is, it will extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
The James Webb and other space telescopes are helping to build a catalogue of dying stars, each one a ticking time bomb in the night sky. The death of Betelgeuse will teach us more about stellar evolution than ever before. By studying its final stages, we'll gain insights into the processes that govern the life and death of stars, the formation of new elements, and the impact supernovae have on the cosmos. Betelgeuse's eventual explosion will mark a new chapter in our understanding of the universe. What we learn from its death will shape our future explorations of galaxies, black holes, and the birth of new stars. Betelgeuse stands as one of the most fascinating and enigmatic stars in our galaxy. Its impending death promises to be one of the most extraordinary events humanity will ever witness. Whether it happens tomorrow or in 100,000 years, Betelgeuse will remind us of the immense power and mystery of the cosmos. As we continue to study stars like Betelgeuse, we uncover more about the origins of the universe, the birth of planets, and the very elements that make up life itself. What do you think? Will Betelgeuse explode in our lifetime? Or will we have to wait centuries to witness its incredible supernova? Let me know in the comments below. And if you enjoyed this deep dive into the mysteries of Betelgeuse, don't forget to like, subscribe, and hit the notification bell for more cosmic explorations right here on Mystery Beyond Reason.